Okay, so we're going to start with another new shape today, surface area of spheres. And so technically a sphere is defined as a locus of all points that are equidistant from the center. So I think earlier in the year we did an activity where Miss Benton stood in the front of the classroom and everybody held a yardstick, and you were all 3 feet away from Miss Benton. And we said, oh, look, conveniently, you guys all form a circle. You are the locus of points that form a circle because you all made yourself 3 feet equidistant from some center point, Miss Benton. So this is the same idea, except for it's in 3D instead of 2D. So if I said make yourself in any direction equidistant 3 feet from Miss Benton, somebody could have stood on the stool and somebody could have gotten down low, and you guys could have been anywhere in three-dimensional space that's still 3 feet away from Miss Benton. So when this happens, so here's my center, and I have all these points, and it's really hard to draw three-dimensional space, but all those points that are all 3 feet away from Miss Benton in every direction, or the center of the sphere, that's what a sphere is, guys. It's all the points that are equidistant from a center. Okay, so a couple other terms here. A great circle is a circle in the sphere, but it's specifically a circle formed by a plane intersecting a sphere so that it contains the center of the sphere. So if you look at this picture here, here is our great circle. So it has to be a circle that is on the rim of the sphere, and it has to contain the center. It can't just be up here. That's just a plain old circle, not the great circle. So the center of the sphere is also called the center of the great circle, and the radius of the great circle is also the radii of the sphere, right? Obviously the center of the circle out to the rim in any direction, that's also the center of the sphere out to the rim of the circle, of the sphere. Okay, and then you can also have, in theory, a plane, you could have it just touch the sphere at a point, at a single point touching the sphere, and we're going to learn later on that's called a tangent plane. But anyway, all right, so a hemisphere. What is a hemisphere? You guys have heard this term before, northern, southern hemisphere, eastern, western hemisphere, in reference to a sphere we are very familiar with called the globe, or Earth, right? So a hemisphere is half of a sphere, but here's the hiccup. It includes the lid. So when we think of a sphere, when we think of the Earth, we think of just half of Earth, right? But technically, as far as like geometric spheres are concerned, it's like you slice this three-dimensional solid in half, but there's this piece right here that's a flat surface, and that gets counted into the whole hemisphere, the whole half sphere. Okay, so some other terms. The radius of the sphere is a segment with endpoints that are the blank of the sphere and a point on the center of the sphere and a point on the sphere. So we've got DC and DA and DB. Those are all radii of the sphere. They don't have to be in the great circle. You could also have a radius going up here. Diameter of a sphere, very similar to a circle. It's just a segment that contains the center of the sphere. So it's a line that goes all the way across the sphere. But like FG doesn't count because even though it goes across the sphere, it doesn't go through the center. So the only diameter shown here is this guy, AB, because it goes all the way across the circle. Its endpoints are on the sphere. And it goes through the center. You could make another one here if you wanted to, though. It doesn't have to, again, be in that great circle there. Okay, so I'm super bummed. Our next investigation would have been really fun in class. It has to do with peeling oranges. And so I'll let you watch the video on peeling oranges to help us figure out what is the formula for surface area of a sphere. And orange, by the way, is going to be our code word for the day.